You very well know that the Apache Spark and Snowflake Snowpark are competitors and they are trying to compete with each other on highly competitive cloud data warehouse market. But as a data developer, we may have a scenario where you have to write a Snowpark program and run it using Apache Spark Databricks Notebook. And that's what this video is all about, covering installing Snowpark library in the Databricks Notebook as well as at cluster level. Snowflake connectivity using session API, loading data using Spark data frame and Snowpark data frame and moving back and forth, and some of the programming limitation when it comes to Snowpark Python, Java or Scala APIs. We will see the storage efficiencies of Snowflake versus Databricks cluster. We are going to use community edition of Databricks and free trial edition of Snowflake. So stay tuned until the end of this video. Welcome back to my channel Data Engineering Simplified, and to this everything about Snowpark playlist for true data professionals and data engineers like you. And in this episode, episode 7, we will see how to use Snowpark using Databricks Notebook. We have already finished 6 episodes in this playlist. We are going to discuss many different topics related to Snowpark which is covered in this 12-part series. You can pause the video, review the topic from this tree map and jump to a specific episode if that interests you. Links for all the videos can be found in the description section or above in the info icon. These videos are recorded in 4K resolution. Follow the instruction for better resolution and to learn it faster. Before we proceed, I have a quick announcement. I have published more than 100 videos covering different topics under different playlists. And if you find it hard to get into a specific topic or a subtopic or a specific concept, use this summary card for a quick search. Summary card download instruction is given in the description below. For additional queries or specific question, feel free to drop me a note to my Instagram account. So let's start. How to make Snowpark library available in Databricks. So in this first part of this video, we will learn how to install Snowpark library in our Databricks notebook. For that, I am using Databricks Community Edition, which you can also get it free of cost. However, it has a limitation that it will provide only one node cluster. You will be surprised to know that Snowflake Spark connector is natively available in Databricks cluster. However, Snowpark Python as well as Scala library is not natively available in Databricks. So here I am in my Databricks Community Edition and this is the home page. Let's create a Python notebook first. Let's first validate if Databricks Notebook has Snowpark library available or not. To validate that, I would try to run this import statement and we'll see if this statement works or not. However, to run this statement, I need to make sure that I first add a cluster. Without cluster, I won't be able to run my notebook. To add a cluster, I have to go to my compute node. And here I can create a compute node. So I am not making any changes in this configuration. And let's create a cluster. If you look into this information, it has 0 worker and it has only one driver node available. And this driver has 15.3 GB of memory, 2 cores and 1 Databricks unit. This may take a while. So from here, I will fast forward so we can save time. If you come back to the cluster homepage, here it will also list down all the cluster which are in a different state. So if you are using Databricks Community Edition, it may happen that your cluster may take longer than expected time, and that's what the big difference between Snowflake versus Databricks, because Databricks clusters are generally slower than the Snowflake clusters. Now my cluster is created successfully. Let's see how does it look like. So it has Scala 2.12.x and it has Apache Spark 3.3.2, good. And it is just a single driver machine. So we can't expect a big performance from this cluster. And if I go to libraries, so I do not have external dependent library installed as of now, and there is no notebook attached with this cluster. So I'm going to attach my existing notebook with this cluster. So here I'm selecting Snowpark demo cluster. Now let's run this import statement and see how does it work. So it says that this module is not found, okay, which is obvious because Databricks natively does not support Snowpark libraries. Databricks server under the hood support Python. So by using this 3 pip install command, I would be able to install Snowpark as well as Pandas module. Let's run this. So this may take a while. So this command took roughly 26 seconds to install it. Now let's rerun this import. Now it got executed successfully. Now once I have this session object available, I can create a configuration parameter and establish a session with my Snowflake instance. So this is my connection parameter. So using this session API, I am creating a Snowpark session object and trying to understand what is the type of this Snowpark session object, just to make sure that yes, my libraries are imported successfully. Let me run this cell. So this piece of command got executed, and this print statement on line number 16 says it is a snowflake.snowpark.session object. Good. Now I have the connectivity established with my Snowflake environment. Let's try to create a data frame using session.sql method. I am creating SF context df data frame, and I am just running current role, current database, current schema, and current data warehouse, and let's print the result. So it is pretty quick. I can see my result displays on the screen. Now I'm going to create another data frame called customer df by running a query and trying to fetch close to 100 records and displaying using the display method. Since it is a Snowflake data frame, the native display method does not work, so I need to change it to show. So my data is working properly and I do not have a challenge. So when you are building a Snowpark solution using a Databricks notebook, you have to be very, very careful that you make it confused and use your Snowpark data frame interchangeably with Spark data frame, and sometimes that command or that statement may not execute as expected. So far we have seen how to install Snowpark library in your notebooks. Now the next big question, I cannot install my Snowpark library in each of my notebook. So is there a better way to install the Snowpark library at cluster level? And that's what we are going to see in our next step. History. Before we jump to our next step, let's quickly understand how the query history screen looks like when we try to establish a connection from our Databricks notebook to Snowflake. So no matter how do you establish a connection from your Snowpark to Snowflake, everything will be registered as a Python Snowpark 1.5.0. And here on my query tag, that is what the differentiator in most of the cases, here it will clearly say this particular program is being invoked from your Databricks notebook and not from your local runtime environment. So this is the first query which we executed to get the context detail, and second query was on the customer table, right? And eventually everything gets converted into SQL in Snowflake. Let's make the Snowpark library available at cluster level. I'm back to my Databricks screen, and let's open this cluster. And I can see there is one notebook which is attached with my cluster. I can click on the libraries, and here I can really add a new library by clicking on this install new. If I have to install a jar file using Maven, then I can click on Maven. And once I click on Maven, I can keep the Maven coordinates. In this case, it is com.snowflake.snowpark. Okay. And I can click on a search packages. I can choose Maven Central and provide Snowpark as a keyword and simply select 1.8.0. Okay, so this has automatically populated the value here. This is my coordinates and click on install. So this may take a while and this cluster will get Snowflake Snowpark library for Java as well as for Scala. So again, I am fast forwarding it because it may take a while. So this got installed. Now the next installation is for my Python library. For that, I have to select this option. And once I have selected this option, it is giving me an instruction that please include the package in this format. If you go to pip installation, this is what the instruction I have it. So I can simply copy this. And this is the minor correction I will do and click on the install button. Again, this may take a while. I will fast forward it. So this got installed successfully. Now let's create another notebook. So I have copied, pasted the code. Here it is importing a session object, defining a connection parameter, creating a session using the session builder method and calling an SQL statement and finally displaying the data. Let's run this. So in this notebook, I have not installed anything. However, an installation is done at the cluster level. Let's run this cell. Now my data is available. It has successfully established the connection and through the Snowflake connection, the Snowpark has executed the query. Looks good. Now let's create a Scala notebook. Now let's try to import this function and let's see if it works or not. So this has worked successfully. It means my cluster level Snowpark configuration is working without any issue and I don't need to import these libraries again and again for each of my notebook. Now let's establish the session object and try to run the show command on the context df. So my is program also executed successfully without any issue. Let's go and quickly check our query activity, how the Scala program reflects on the query activity. So if I look into my query activity, the query tag looks slightly different and it has com.snowflake.snowpark.dataframe.show. There are a lot of inner function which is the nature of the Scala program. And that's why you will see this $read and $iw init and command. Okay, it means that this is a Scala program and not your Python program. And this is how the Python program query tag looks like. However, by looking at this command, it is little hard to understand whether this query is executed through Databricks Notebook or from your local machine. Now, one of the limitations Databricks Notebook has that it does not allow you to write a program using Java programming language. And if you are trying to build a Java-based Snowpark solution, you cannot use Databricks notebooks. However, you can really create a jar file and that jar file can be added through this library and you can execute that jar file as a Snowpark program. So this is how you can configure your Snowpark, Scala, Java and Python libraries and you can build a solution using Databricks notebooks. Now let's quickly interact with Snowflake using Snowpark and load a large dataset and see how the overall program looks like, how we can use Apache Spark, Pandas and Snowpark program together and exchange the data between these two platforms. I have already created a notebook called Data Loading to Snowflake Notebook. Let me open this. And first I will attach a cluster. So this is my Databricks cluster. So now the cluster is attached. I have two files called customer files and order files. The customer files are available in Parquet format. Order files is also available in Parquet format. And the size of this Parquet file is 157 MB and this is 52 MB. And this is how the customer and the order looks like. So customer has customer ID, name, address, country, mobile, balance, segment and comment. And order ID, customer ID and rest of the information and they are interconnected using this customer ID. Now let's load this data first and validate if it is getting loaded properly or not. So since it is a Spark cluster, it will primarily initiate a Spark job. So the data is loaded successfully and I can really run select a statement on this customers and order tables. Let me do that. So this is how my customer looks like, and let's see how the orders looks like. So this is how the order data looks like. And if I try to do the count, so my order has 1.5 million rows and my customer has close to 2 million records. Looks good. I will run a piece of Scala code to see how big this file is, because I want to compare the file size stored in my Databricks versus actual file size when it is going to be stored in Snowflake. So it's a pretty straightforward piece of code, and I'm going to understand the size of this customer parquet file. Let's run this cell. So it says it is close to 150 MB when stored in a Databricks environment. When I change this file to order parquet file, let's see. So it is close to 50 MB when it is stored in Databricks file system. Looks good. Now let's establish a connection with Snowflake and create a session object. So far code is running good. So I am going to create customer DF and order DF using the Spark API and not the Snowpark API. So don't get confused with the customer DF and orders DF. Let me quickly run them. So I managed to create customer DF and orders DF. So let me first run the count on the customer DF and order DF and print them. So this is the record count, looks good. So since I am operating on Spark data frame, I cannot really convert this data frame into Snowpark data frame. I have to take help of Pandas data frame, because Pandas data frame is a common data frame between Spark data frame and Snowpark data frame. So what I'm going to do, I am first going to convert my Apache Spark data frame into Pandas data frame, and using that data frame, I am going to create a table in Snowpark. And let me quickly write the piece of code for you. So the line number 3 is actually converting to pandas, and once it is converted to pandas data frame, then I am using create data frame function from the session object and converting this pandas customer data frame to Snowpark customer data frame, and then using the write function I am writing into a customer table. Okay, let me execute this command. So it got executed successfully, and let me do it for the order table also. So it took roughly 38 seconds to write the data into the orders table, and this particular command, it took 1.23 minutes to write into the customer table. Now let's go back to Snowflake and check how these tables look like. So this is my customer table and this is my orders table. If you look into the customer table, it has 1.9 million rows, and the total size it has occupied in Snowflake is 103 megabyte compared to 149 megabyte. On the other side, orders table is taking 38.8 megabyte and total 1.5 million rows. So both of them have shown roughly 25 to 30 to 32% of storage saving compared to Databricks file system. And if I try to see the copy history, this has not executed copy command to load the data. Now let's go and check the query activity. So if you look into this create table, it has actually created a table using a select star from, and for the select star from, it has used some temporary table to load the data. So this is how the table is created using Databricks Notebook through the Snowpark API. And this query tag is clearly saying that it is executed through the Databricks Notebook. Let's see one more example where we are going to fetch the large amount of data from Snowflake to Snowpark Databricks Notebook. For that, I'm going to run a join query using our session object through SQL method. So this is my select statement, which is joining order tables and customer table. Since table is created directly from my data frame, it will have the column name in lowercase. For that, you have to specify the double quote along with your column name, else it will not work. When I run this particular statement, it does not do anything because Snowpark is also evaluated lazily. So next. When I run the collect statement, it will actually execute this query. Let's see how much time does it take to run the query. So it took 5.38 seconds and displayed all the data. It has total 25 records where customer and order tables are matching. So all my 25 records are displayed on the screen. Looks good. So if I look into my query history, this is how my query looks like. So second query where I ran the show statement, it actually executed like this. And for the first statement, it has executed this join query, right? So my collect statement fired this query and my show statement fired this query. And both of them executed from my Databricks environment. Looks good. And if I see the duration, the collect took 2.2 seconds and the show took close to 1 second. However, my Databricks took 5.38 seconds to display the result. So pretty fast, both of them. So this is how you can really write your program by combining Apache Spark, Pandas data frame, as well as Snowpark data frame object. And you can perform a complex activities by loading, unloading data between your Snowpark as well as your Apache Spark environment. I assume this chapter has thrown enough light on Snowpark and Databricks Notebook integration with working example. Thanks for watching episode 7. Our next awareness chapter, chapter 8, will be even more interesting, where we will learn how to run a Snowpark Python program inside a Snowflake secure sandbox and what changes are needed to run your Snowpark program and the procedure to deploy your Snowpark file into Snowflake secure sandbox. So don't forget to watch next episode, episode 8. If you have learned something valuable from this episode, don't forget to press on the like button and share with other data engineers and Snowflake developers. Happy learning and keep growing.